So in this video we're going to look at finding equations of lines that are perpendicular to a particular line. So as you can see here on my axes, I've got a line going in the positive direction and a line going in the negative direction. Now the equation of this line is actually y equals x, and the equation of this line is actually y equals negative x. Now because I've made sure that the grid is square, completely square, we can see that that's got a gradient of 1. Look at the rise over the run. The rise is 1, the run is 1. Look at the negative line. The rise is 1 or negative 1 and the run is 1. So we can see that it's completely square. Now what we can also identify if we know angles of squares is that we know that there's right angles in squares. Well, if you look at this one, it cuts exactly the square through the diagonals, which means it's 45 degrees through the square. Now add together the two 45-degree angles and you get a 90-degree angle. That means that these two lines cut each other perpendicular, because perpendicular means that it cuts through at exactly 90 degrees. Okay, so I've written that there. Now let's look at some properties of perpendicular lines. Let's suppose that the gradient of this line is m1 and the gradient of this line is m2. Okay, so let's just write that down. We've got that m1 has a gradient of 1 and m2 has a gradient of negative 1. Now a property is if you multiply the two gradients of perpendicular lines together, you get that m1 multiplied by m2 should always equal negative 1. Now that's a property. Okay, it's a property of perpendicular lines. Also we can say that if m is this particular number, then m2 being the perpendicular line, that's the negative reciprocal of m1. So in this case we can also say that m2 is minus 1 over m1. And I've put that in a purple box. Okay, let's do an example. So we're going to decide if the lines are perpendicular. So the first equation I'm going to give you is y equals negative 3x minus 8. And the second equation I'm going to give you is y equals 1/3, sorry, let me just rub that out, 1/3 x plus 1. So we're looking at these two properties above. So let's look at the gradients, because it's gradients that are really important. The gradient of the first line is minus 3. The gradient of the second line is 1/3. So what we need to do is multiply those two gradients together to see if we get negative 1. So negative 3 times 1/3 is negative 1. Check. We don't need to check both properties, but just out of interest, let's look at the second property that we wrote down here. Is this the negative reciprocal of that? Yes. Therefore, these two lines are perpendicular to each other. Let's do a second example now, where we are finding the equation of a perpendicular line. Find the equation of the line perpendicular to y equals 3/4 x minus 1 that passes through the point 3, negative 2. So let's have a look at the gradient of the first line. The gradient, which we'll call m1, is 3/4. Okay, so we can highlight that here in the question. Now we want the negative reciprocal of that. So the negative reciprocal, remember we flip and becomes negative. The negative reciprocal is negative 4/3. Then what we do is we then write in the equation y equals mx plus c, because remember the line is perpendicular but it's still a straight line, so it follows this simple rule. So I'm going to now just substitute our new gradient here into the equation. So I'm going to put negative 4/3 in, and then finally I'm going to use my coordinate that we were given in the question and let x equal 3 and y equal negative 2, and substitute those values into this to find our value of c. So let's do that. Negative 2 equals negative 4/3 multiplied by 3 plus c. Okay, so let's do that. So negative 4 times 3 is negative 12/3, which is just negative 4 plus c. And then finally adding that 4 over to the other side gives us the value that c equals 2. Therefore, the equation of our line that is perpendicular is y equals negative 4/3 x plus 2.